Good morning, class 8. Today from chapter 10, that is visualizing solid shapes, I am going to discuss some important definitions related to polyhedron. So let's start. So here definition of polyhedron. A three-dimensional shape is made up of polygonal region is called polyhedron. So let's understand the meaning. Three-dimensional, first of all, a figure in which length, breadth and height are lying together. And now lateral faces. Here we are using the word polygonal region. So polygonal region means to say the lateral faces will be in the shape of polygon. So look here example. In the first figure, this is example of a quadrilateral pyramid. So here this is a three-dimensional shape and all the lateral faces are polygonal. Okay, so this is the example of polyhedron. Now look this second one. In the second figure we are seeing a cuboidal shape in the bottom and one quadrilateral pyramid is surmounted on that. So this is an example again of a polyhedron. Now look here some more example. Here in the first one, these four figures are the example of polyhedron as the definition. According to the definition, the three-dimensional shape. So all the shapes are here three-dimensional and made up of the polygonal region. That means the lateral faces are in the polygonal shape. Now look here the second one. These are not polyhedron. Why not polyhedron? Because here all the three-dimensional shapes. So first point is lying here, but according to the second point, that means the polygonal shape at the lateral faces are not lying. So here first figure is the sphere. So here surface will be the curved surface, and here second one is a cylinder. Again the surface is a curved surface, and here in the cone the surface is the lateral. That is a not the polygonal in shape. So that's why the second figure here, which is sphere, cylinder and cone, are not the example of polyhedron. Now next is the convex and concave polyhedron. Now to understand them, already we know what the convex and concave. In chapter 3 we have discussed them. So convex means to say a polyhedron in which all the diagonals will lie inside the figure. So here in the first and second figure, all the diagonals always will lie inside the figure. So these are convex polyhedron. But look here in these two figures, diagonals will lie outside the figure also. So these are not the example of convex polyhedron. So in that case, these are the concave polyhedron. Now next is regular and irregular polyhedron. So look here, we have two figures. In first figure we have a cube. So here what are the properties by which we are saying that this is a regular polyhedron. So here in the first figure there are 3 points to be a regular polyhedron. Number 1, the polyhedron must be regular. Number 2, faces must be congruent and vertices are formed by the same number of faces. If it is so we can say the given shape will be a regular polyhedron. And in the case if any one point is not lying in the figure, that time the figure will not be regular polyhedron and we'll call it irregular polyhedron. Now look here in the first one, this polyhedron is regular. So in the cube we see all the sides, all the faces are regular in shape, that is a square in shape. And second one, if it is a square then faces will be congruent. And third point, vertices are formed by the same number of faces. So if you will see, suppose at this point, so at this vertices how many faces are meeting? So 1, 2 and 3. Total number of faces are 3 here. So if you will check at all the vertices, there are equal number of faces will meet that point. Okay. Now look here in the second figure. This polyhedron is not regular as the faces are not regular. And second point, all the sides are congruent. Sides are congruent meaning to say here side, if you will measure the side length of this side will be equal. But the vertices are not formed by the same number of faces. You look here at this point A, at this vertices A, there are 3 number of faces are meeting, 1, 2 and 3. But at the B point there are 4 faces, 1, 2, 3 and 4. So that's why number of faces are different at the two vertices. So this figure will not be a regular polyhedron. That's why we'll call it irregular polyhedron. Now, next to important definition of this chapter, prism and pyramid. So look here, these two shapes. We have first one is the cubical shape and second one is the prism. Okay, so what are the definition of prism? Prism is a polyhedron whose base and top are congruent polygon. So look here, in both these shapes, top and bottom are congruent. And next point, and whose other faces, that means the lateral faces are parallelograms in shape. So here lateral faces are parallelogram, that's why these two are the example of the prism. Now next is the pyramid. So what are the pyramids? Look here, a pyramid is a polyhedron whose base is a polygon of any number of sides, but minimum number of sides must be 3. Less than 3 side polygon will not be possible. You know this one. So here in the first shape you are seeing at the bottom this is a polygon with a 4 number of sides, and here this second one is the 3 number of sides. Now next point, and whose lateral faces are triangles with a common vertex. So look here, lateral faces all are triangular in shape in the first figure, even in second figure also, and all the faces are meeting at the common vertex here in the first figure and here in the second figure. So that's why these are the example of pyramid. Okay, if someone asks what is the difference between the prism and pyramid, so here first difference is in prism top and bottom must be congruent while it is not happening in the pyramid. And second difference is that lateral faces are parallelogram in prism and lateral faces are triangular in the pyramid. So these are the two main differences between prism and pyramid. Now children, for today I am giving you this work to do. Look here in this table. We have in the first column solids name, in the second column F for faces, V for vertices, E for edges. In the next one F plus V, that means the sum of faces and vertices. And in the last column we have E plus 2, that means number of edges will be added by 2. Okay, and where you will find these all from this first column. So here you have to draw these shapes, three-dimensional shapes: cuboid, triangular pyramid, triangular prism, pyramid with square base, and prism with square base. And from that find out all these faces, vertices, edges, and here take the sum of F plus V, and here the sum of E plus 2. Okay, and after finding it, the next important definition, or we can say the rule, we will discuss in the next class. Okay children, thank you for today.